Hello, my name is Kengo Nagashima. I'd like to thank the ESMARConf2023 organizing team for kindly inviting me to speak here today. I'd like to talk about pimeta package, which is an R package for prediction intervals for random effects meta-analysis. Random effects meta-analysis combine the treatment effect estimates across studies, accounting for heterogeneity. One of the objectives of a random effect meta-analysis is to summarize studies and to make statistical inferences on the average treatment effect. Quantification and variation of the magnitude of heterogeneity are also very important because true treatment effects can differ for each study due to differences in patient characteristics, follow-up times, drug regimens, and other factors in many cases. However, researchers often interpret results from random effect models in the same manner as those from fixed effect models, that assume the true effect does not differ from study to study. So, a prediction interval was proposed. Prediction intervals can be interpreted as the range of the predicted true treatment effect in a new study. Prediction intervals provide useful additional information to confidence intervals because a prediction interval is a measure of treatment effect that accounts for heterogeneity. It was recommended that a prediction interval should be reported alongside a confidence interval and heterogeneity measures. You can find existing methods in this list. Several methods to construct prediction intervals for random effects meta-analysis has been developed. The method of Higgins et al. Is most commonly used. This method could have poor coverage when the heterogeneity of the number of studies is small, because this prediction interval is based on large sample approximations. So, modified method was proposed. Hard-to-learn graph, Kenward-Roger, and bootstrap methods can be used. These prediction intervals have better coverage when the heterogeneity or the number of studies is small. Now, I'd like to show you the pimeta package with examples. This package is easy. Load your data and then pass it the pima function. The Threelan website has examples that are described here. This slide shows an example code with a package example data. Outcomes are continuous values in this data. Y is the vector of effect size estimates. SE is the vector of parameters of the within study standard errors. B is the number of bootstrap samples. Seed is the random number seed. Parallel is the number of threads used in parallel computing. Here we have a result calculated with the pimeta package. Unestimated results can be summarized by the print method. Both prediction and confidence intervals and summary statistics that are usually reported in the random effect meta-analysis are provided. An estimated result can also be summarized by a forest plot by the plot method. The forest plot function has an argument study labels to set the labels for each study. Now, I'd like to show you an example of binary outcomes. The pimeta package can handle random effects meta-analysis with binary outcomes. The convert bin function converts binary outcome data to effect size estimates and register these standard errors vector. This function has an argument type that is a character indicating an outcome measure. Log odds ratio, log risk ratio, or risk difference can be specified. Finally, input data m1, n1, m2, n2, which are integer vectors, are converted to effect size estimates and resist the standard errors. Estimated values on the logarithmic scale can be back transformed to the original scale with the trans option in print and plot functions. Here, you can see a forest plot for binary outcome. The trans option can also be used in the plot function. Now, I'd like to show you another features of the pimeta package. The pimeta package has cima function for confidence intervals. Many methods to construct confidence intervals for random effects meta-analysis have been developed. This function supports 8 types of confidence intervals listed below. Next, the pimeta package has tau-squared hat function for heterogeneity variance estimators. Many methods to construct heterogeneity variance estimators for random effects meta-analysis have also been developed. This function supports 12 types of point estimators and 2 types of interval estimators. Finally, here is some important additional information. Some functions from the pimeta package can also be used from the meta package. This slide shows an example code using the meta package. The meta package can also be used to create beautiful graphs. Here, you can see a forest plot using the meta package. You can also use other useful functions that implemented in the meta package. Future updates will include enhanced graphics capabilities, adding other prediction interval methods, adding other confidence interval methods, heterogeneity variance methods. And I'm also now working on prediction interval methods for meta-regression. If you have any other ideas, please let me know. I briefly summarize the recent developments in methods of prediction intervals for random effects meta-analysis. And I introduced the pimeta package. The pimeta package provides a function to compute a prediction interval and generate a forest plot for the estimated results. Thank you for watching this video. どうもありがとうございました。